Hi, welcome to the video. This is a question for AP Physics C Mechanics students from the practice exam 2024. This force that you see is the non-uniform force. Force because this force is a function of cos is a function of x, and it is represented by a cos wave, and you know that the cos wave is always starts from the maximum. And so if I try to draw it, then this is a cos wave, the one half of a cos wave, right? So this is a force. How it is changing with respect to x is given by this equation. So what is the work done by this force? That is what we need to calculate. Now you see that this force is applied on the box at some angle theta, whereas due to this force, this box will travel a distance from 0 to d, some distance from 0 to d, and this force is actually less than mg. So, what is the work done during this displacement covered? We have to find it. Let's apply that integration process a little bit later. I will tell you few things before that. We know that the area under the force displacement graph is the work done. So basically, whatever equation we are going to apply, that will give you the area under the graph, right? So means that the area under the curve. And secondly, the force applied by the rope is a non-uniform force that is not entirely doing work. The one component of the force, okay, students, you know that this is a component of the force. So if I write its value, so it is F rope cos of theta. This is an effective component that is adding up energy to the system, that is doing work on the system. But this is a useless component, so that is not doing any work because it is perpendicular to the displacement. So let's imagine that due to this force, it has covered the distance displacement d from its from its reference position, which I'm considering this is a reference position. So how much work will be done? That work is always equals to the integral of force and dx, because this force is changing, and what is a lower limit, that is 0, and the upper limit is d. But wait a second, let us quickly analyze, is the only rope force is doing work or any other force? So I will just quickly show you. So this is a normal force that is perpendicular to the surface, and this must be the weight, which is obviously more than the normal force. So both are not doing work because the object is dragged on a horizontal axis, right? And what about the other forces? There's just one other force, and I'm going to just draw the components. This is a x component, and this is a y component. Y component is not executing work, which I have already explained you here, but the x component is doing work, and that is f rho cos of theta. So we are going to exactly show here, we are going to substitute here that component. So this is from 0 to d, and the this component times dx. Now notice one thing, the force all the time is applied at a same angle theta, all the time, even at that time when it covered the displacement d, it is still theta, which means that the cos theta is not a variable component, and we are not integrating it, this expression, with respect to cos theta. So why not we should take it out, because it is not going to be integrated. So inside we have now 0 to d, and by the way, the force applied by the rope is the function of x represented by the cos, and here we have this thing, right? So when you will try to find out the integration of the cos, that is equals to 1 over beta, means this beta which is inside its power, and its integration is sine beta x, and from 0 to t. So, dear students, I have written this equation according to the, whenever we take a integration of cos, for example, a theta, right? And you are integrating with respect to theta, let's say, then this the whatever the coefficient is inside the power, that is always divided. Okay. And the integral of the cos is sine, so that's how we have written this. Okay. So now we are going to substitute the value. So this is our definite integral. We know the lower and upper limit. That's why we have not added any component, any constant, sorry. So this is cos theta inside, and you can divide it here, right? Beta. Inside, you can apply the lower and upper limit. So it will be sine beta. You can put the value of x equals to d, and minus sine into beta x is 0. So now that is finally equals to 1 over beta cos theta. Inside you have sine into beta t, and sine 0 is always 0. Okay, so you can see that this should be option D, obviously.